Welcome back. Let's do question 6. In the diagram below, the graph of f of x is drawn, which is 2 cos x, right, for this interval from negative 180 degrees to 180 degrees. Right, on the grade below, draw the graph of g of x, and g of x is called negative cos 2x, and then for the same interval there. Clearly show all the intercepts with the axis and the turning points of the graph. So there are many ways we can sketch this graph of g of x. Let me start with the calculator method. Okay, I'll show you how to use the calculator, right? And then after that, we're going to draw this graph from the parent graph. So I'm going to show you two methods. Right, now when using the calculator, we have to determine the steps that we're going to use in the calculator, right? And then I want you to treat this like a formula. The step is equal to period divided by 4. Please remember this. Right, now we have g of x is equal to cos 2x. If we have a function of the form y is equal to cos kx, what is the period? How do we find the period here? We have to remember that period here we use 360 degrees divided by k, isn't it? Right, we say 360 degrees divided by k. That is for the cosine graph and also for the sine graph. For the tangent graph, we say 180 degrees divided by k. Right, so it means the period here is going to be 360 degrees divided by 2, which is equal to 180 degrees, right? And then we're going to use this to get our step. So for our step, we're going to say 180 degrees divided by 4, and then is equal to 45 degrees. So we're going to get points every 45 degrees from negative 180 degrees up to 180 degrees. Then we can use the calculator to do this. Let's check how we use the calculator. Alright, this is how you use your calculator. You press mod and then you look for table. In this calculator it is number 7, so you enter table there. And then now you can enter your functions. Our function is negative cos 2x, so it is negative cos and then 2, and then our x, press alpha, and then there's x here just on top of the closing bracket, and then you close your bracket. Okay, this is the function. Press equals. Right, now we don't have the second function, so let's ignore this by just pressing equals. And then start. We're starting at negative 180 degrees, so you enter negative 180 degrees, and then equals, and then ending, we're ending at 180 degrees, and then press equals, and then step. We said that our step should be 45 degrees, so we want points every 45 degrees from negative 180 degrees there. So equals. So these are the critical points. At negative 180, the graph is at negative 1, negative 135, 0, negative 90 degrees, 1, and then negative 45 degrees, 0. At 0 degrees is at negative 1, like that. So you have all these points that you can record, and then after that you plot your graph using them. Let's plot the graph. Alright, we managed to get these points from the calculator. At negative 180 degrees, the graph is at negative 1, so it means it's here. And then at negative 135 degrees, the graph is at 0. At negative 90, the graph is at 1. At negative 45, the graph is at 0. At 0, the graph is negative 1. At 45, the graph is at 0. At 90, the graph is at 1. At 135, the graph is at 0. And then 180, the graph is at negative 1. Okay, then we can easily sketch our graph. This is our graph of g of x. The turning points, the x and y intercepts are very clear. You can easily see them there. Okay, right, very clear. Okay, this is the y-intercept, x-intercept, 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 turning points there. And then also the end points must be very clear when you're sketching of graphs. These ones we don't need to rewrite because it's very clear where the end point is and also all the critical points are. So we can have our graph like this. But otherwise, if it's not clear, we're supposed to write the coordinates here like negative 180 degrees and then negative 1. So everywhere we write the coordinates. But this one can leave it as it is because the points are very, very clear. Okay, right. And then I said we can also sketch the graph from the parent graph. The parent graph being y is equal to cos x. We must know the critical points of this graph. So at 0 it is at 1, at 90 it is at 0, and then at 180 it is at negative 1. This is the parent graph. Okay, and then at 90 0, negative 90 0, negative 180 negative 1. Okay, and then this is the parent graph like this. Okay, let me use dotted lines. This is the graph of y is equal to cos x. Right, what is the effect of this negative 1? This is a reflection about the x-axis. So let's reflect this graph about the x-axis. If you reflect it about the x-axis, it's going to be like this. We've done the effect of negative 1. And then what is the effect of these two? The effect of these two, the graph, the period of the graph is halved. The period of this original graph, the red one, is 360. Now the period of this one is going to be 180. So the graph will repeat itself every 180 degrees. The graph will start here. It's going to be negative 45 there instead of negative 90, and also at 45 there instead of 90. Right, and then at negative 90 is going to be negative 1. You see the graph now repeats itself every 180 degrees. So this is a complete cycle for the graph from negative 90 to 90. That's 180. And then the graph will continue again from here. You see that, and then the period now is now halved. It's now half of 360. Okay, right, and then this is the graph you're supposed to sketch. So you can also sketch the graph from the parent graph, but a lot of people find it easier to use the calculator. Okay, so you can use the calculator, get your points, and then you just you just plot them. It is better to understand the transformations that happen to the parent graph to form your graph, so that even when you're using your calculator, you know how your graph should be shaped, isn't it? 6.2, write down the period for 2g and then x plus 10 degrees. This is our graph of g of x. So g of x is equal to negative cos 2x, right? So what would be 2g of x plus 10 degrees? Right, this becomes 2 negative 2 because of this negative 1 there, negative 2, then cos, then 2, and then where there's x, we put x plus 10 degrees like that. Okay, so still this is the parameter that affects the period. Okay, so the period will be still 360 degrees divided by 2, which is 180 degrees. So the period is 180 degrees. Please take note of this. So you can be like cos kx, k affects the period. You say 360 divided by k. Even if it's like this, cos and then k x minus p like this, just know that this k is the one that affects the period. So you divide 360 by k. That is for the cosine graph and the sine graph. If it's tangent graph, remember we say 180 degrees divided by k. Okay, so the period here is 180 degrees. Right, use the graph to determine the values of x in the interval 0 to 180 degrees. So from here, for which f of x times g of x is less than or equal to 0. So what does that mean? This is a product. We're multiplying these two things. So it means it's either this one is positive, then this one is negative, or this one is negative, then this one is positive. Okay, or they are equal to 0, isn't it? Because saying less than or equal to 0. So like I always say, the graphs change their sign at what? At their x-intercepts. They change from being positive to negative, or from being negative to positive. So we have this x-intercept here, 45 degrees. That is for g of x. This is g of x, and then f of x. And then we have here at 90 degrees. We have here at 135 degrees, like that. Okay, let's check between 0 and 45 degrees. G of x is negative, f of x is positive. Why am I saying that? The graph, if the graph is above the x-axis, means it's positive. And then if the graph is below the x-axis, it means what? It's negative. So this one, g of x times f of x, will give us a negative answer. So we want this region is fine. Okay, we're going to write our answer at the end. And then let's check between 45 degrees and 90. G of x is positive, f of x is positive, because both graphs are above the x-axis. So if you multiply them, they are going to give us what? A positive answer. We want negative. Less than 0 means negative. Greater than 0 means positive. Right? And then between 90 and 135. Between 90 and 135, g of x is positive, f of x is negative. So we want this. G of x is positive, f of x is negative. So if we multiply them here, they are going to give us a negative answer. And then between 135 degrees and 180 degrees, both graphs are negative because both of them are below the x-axis. So this one is out because negative times negative will give us positive. Now let's write our answers. So we have to be careful here. So it means x should be an element of 0 degrees included. 0 must be included because we are saying should be less than or equal to 0. So we have to include the 0 here. And then 45 degrees also included. Okay, right. Or you can write like this: x less than or equal to 45 degrees, but greater than or equal to 0 degrees. Okay, right. And then we have this region again from 90 to 135. So you can say x an element of 90 degrees to 135 degrees, right? Included. Okay, included. Or you can say x less than or equal to 135 degrees, but greater than or equal to 90 degrees. Okay, so these are your answers there. All right, 6.4. Write down the maximum value of f of x minus g of x. So f of x minus g of x must give us a maximum value if f of x is at its maximum and g of x is at its minimum. Okay, so f of x is at its maximum here, and then g of x is at its minimum here. So it means we have a 2 here. This is 2. So it's 2 minus negative 1. So that be 2 minus negative 1, meaning that is 3 units. Okay, so the value of f of x minus g of x, the maximum value of f of x minus g of x is 3. Then 6.5, determine the range of y is equal to 2 to the power 2 cos x plus 2. Right? So please take note of this. The range of this is going to depend on the range of this, isn't it? So we can get the range of 2 cos x plus 2. And then that will determine the range of y here. Y is equal to 2 to the power 2 cos x plus 2. So let's start by getting this range. So 2 cos x plus 2, this is like 2 cos x, isn't it? And then plus 2, the graph is shifted by 2 units upwards. The graph is shifted by 2 units upwards, meaning that the minimum now becomes 0. And then the maximum is going to be 4. 2 plus 2, that will be 4. You see that? So now the range for 2 cos x plus 2 will be y less than or equal to 4, but greater than or equal to 0. From 0 to 4. That's the range. Okay? It means the minimum of y is equal to 2 to the power 2 cos x plus 2 will be like y is equal to 2 to the power 0. This one. Right? And then the maximum will be at y is equal to 2 to the power 4. You see that we're replacing this 2 cos x plus 2 by the range from 0 to 4. So from 0 to 4 there. So meaning that our y will be less than or equal to 16 from 2 to the power 4, but greater than or equal to 1 from 2 to the power 0, like that. That's the range there.